proportional relationships and equations. So we've talked a lot about proportional relationships, and we know that in order for any rates to have a proportional relationship, they have to have that constant rate. They have to have that constant of proportionality. And we know how to find that in tables. We know how to find that in a graph and what those look like. And now we're going to talk about how we can create an equation when we find them. And then not only that, how can we look at an equation and determine, is that a proportional equation or not? All right, so let's start with a little example here. We have a situation where we're at the store and we're purchasing cashews. And the first thing we want to do is we want to show that the relationship between the number of pounds and the number of cashews and the cost is proportional. And then I want to write an equation for the relationship. Okay, so I need to write an equation, and I need to show the proportional relationship. So what do I need in order to show the proportional relationship? Well, I need to know what two things I'm comparing, and in this case, I'm comparing the pounds of cashews to the cost. All right, so we get 2 pounds of cashews for $5, and we get 3 pounds of cashews for $7.50. And we get 8 pounds of cashews for $20. Now we talked about before how to set up our rate, and sometimes we just read it to ourselves and say, okay, does this make more sense as dollars per pound or pounds per dollar? And in this case, we know that dollars per pound makes more sense because you're going to pay a certain amount of money for every pound of cashews that you get. You're not going to get a pound of cashews for every dollar amount that you give them. That's not how grocery shopping works. You have to actually figure out what you want and then pay for it based on that. All right. The other thing is we talked about independent and dependent variables. So our independent variable here would be the pounds. You can choose however many pounds of cashews you'd like to. There's nothing that determines how much we have to get. And in this case, the dependent variable is the cost. The cost does depend on how much we purchase or how many pounds we purchase. And then we also have to remember that the dependent variable is always our x, and the independent variable is always our x, and the dependent variable is always our y. And then that makes sense too because our rate is always going to be set up as y over x. And that's always how you're going to find that constant of proportionality for an equation. You can use it to find it in a graph, and you can use it that way to find it in a table. It's always set up as your dependent over your independent. All right, so in this case, we're going to go ahead and we're going to set those pieces up. And we have our $5 for 2 pounds. And we have our $7.50 for 3 pounds. And we have our $20 for 8 pounds. So to determine if these do have a proportional relationship, I'm going to find each of their unit rates. And if their unit rates are the same, then they are proportional. So in this case, I'm going to divide each of these by 2, and I get $2.50 for 1 pound. I'm going to divide each of these by 3, and I get $2.50 for 1 pound. I'm going to divide each of these by 8, and I do get, and just in case we're unsure, we can pop off to the side, 20. 8 goes into 20 2 times, minus 16 is 4. I add a decimal and add a decimal so I can add a 0. I bring down to 0. So I have 40. 8 goes into 45 times. I'm left with 0. So this is 2.5. And we know that with money, that 2.5 means $2.50. And that's still for 1 pound. So we've proven that this is proportional because they all have that same unit rate. So since they all have that same unit rate of $2.50 per pound, we know that it is proportional. Now the next thing we want to do is we want to look at how can I use this constant of proportionality, which we said is K. So K is $2.50 per 1 pound. This can also just be written as 2 and 50 hundredths to make it easier to work inside of our equations. So again, we said that y is the dependent variable. So I'm going to find y by using x. So we find y by using x. And if the relationship is proportional, that's a long word to write. So if the relationship is proportional, I can also use the constant of proportionality. And I'm just going to put that as K. So what I'm looking at here is I want to get y. So what is y equal to by using x? Well, I know that if I take the number of pounds of cashews that I want and multiply it by this $2.50, that should tell me how much it's going to cost me. So I'm taking the 250 and I'm multiplying it by x. This is what your proportional equations are going to, or equations that represent proportional relationships, that's what they're going to look like. They're always going to look like y is equal to your constant of proportionality times x. Because we know we can use x and multiply it by the price per pound to get y. Now we're just setting up that equation. It's always going to follow this form of y equals k times x. So let's take a look at the next page. The next page is a little bit more in depth. And it's your mother has accelerated onto the interstate, beginning a long road trip, and you notice that the fuel light is on, indicating that there is half a gallon left in the gas tank. The nearest gas station is 26 miles away, and your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make it to the next gas station before the gas runs out. Okay, so here's our question. Here's what we want to get done. We're going to use the information from the table to determine if we're going to make it. Okay, so what this means to me then is if I can figure out if this relationship is proportional, then I can create an equation to figure out if I can make it that far. So if I take a look at the fact that she's 26 miles away from the nearest gas station, I want to keep that in mind. So 26 miles away. And then all this information in the table is important as well because it's going to help us determine whether or not she can get there. So when she had 8 gallons of gas, she drove 224 miles. So we have to decide, is the miles driven dependent on the gallons or are the gallons dependent on the miles driven? You can fill up your gas tank however you want to, with however much you want to, but how much gas you have does determine how far you can drive. So again, we can set up our rates and we can determine if there's a proportional relationship. So I have 224 miles per 8 gallons, and I can find the unit rate of that. And if I take 224 and I divide it by 8, so 224 and I divide it by 8, I get 28. If this relationship is proportional, I'm going to be able to use an equation that I can create to figure out my answer. So hopefully these next few work. So I have 280 gallons per 10 miles. I can divide both of these by 10. I know 10 divided by 10 does give me 1. And I know 280 divided by 10, I can cross out the zeros. 28 divided by 1 is 28. So far, so good. And then my next one is 112 miles per 4 gallons. Going to divide by 4. 4 goes into 11 2 times. 11 minus 8 is 3. 8 goes into 4 goes into 32 8 times. So I again get that 28 miles per gallon. So since the relationship is proportional, I can create an equation, and then I can actually figure out, based on the number of gallons of gas that I have or want, how far I'll be able to go. So let's take a look at that. We said the relationship is y equals the constant of proportionality times x. So if I take, I'm looking for the number of miles that I can go, and if I take my constant of proportionality, which is 28, and multiply it by x, that should tell me how far I can go based on how many gallons I put in. And that, again, will tell me how many miles I can go. So in this case, we want to know if, since it's 26 miles away, I'm not going to put 26 in here because x represents gallons. Okay, so we have to look for how many gallons does she have left? Well, she has half a gallon left. So we have y is equal to 1/2 times 28. And actually, I'm going to write that in the same order so it doesn't get confusing. I'm going to keep that constant of proportionality first. So y equals 28 times half. So the miles that she can go is equal to her constant of proportionality times how many gallons she has. And if I do that math, I get 28 over 2, which is equal to 14. So our mom is going to be able to go 14 miles on her half a tank of gas. Unfortunately, it doesn't really look like she's going to make it to that next gas station. Most of all, we need to remember that a proportional equation, or an equation that demonstrates a proportional relationship, is always going to have the form of y equals k times x. Always ask yourself, how can I use x to figure out y? How can I figure out how my independent variable can get me to my dependent variable?